Here we go. What is it in an equation that makes it quadratic? What is the one thing you must have?
Squared?
Something squared. Okay? So the easiest quadratic to use to show you guys how this works is y equals x squared. That's the simplest one. Nothing's happening. Okay? Now, if we were in grade 9 and I told you to graph this, what mathematical tool would you use to graph it? How would you make a graph of that?
Table of values.
You would use a table of values, right? Thank you for not saying T-chart. I know, but you've been in my class before. X and Y. Now, if you were going to do this with X and Y, you should have some negatives and some positives, right? So we're going to use -2, -1, 0, 1, and 2.
0. I think you mean not.
Not. Yes, we're going to use not. N-A-U-G-H-T. Not.
Yeah, it's way better.
Yes, that's British for 0 in case anyone cares.
All right.
So when X is -2, what's Y? Somebody said it. It's not a trick question. 4. When X is -1, what's Y? 1. When X is 0, what's Y? Not. When X is 1, what's Y? 1. And when X is 2, what's Y? 4. So let's graph it. We got a point at 0, 0. We got a point at 1, 1, -1, 1, 2, 4, -2, 4. And it gets us this fancy schmancy curve that we've seen a lot that is called a parabola. Yes, Kelvin. X and Y the wrong way around. What?
Do you have your X messed up?
-2 in for X. -2 squared is 4, so Y would equal 4. I'm very confused by what you're even asking me.
I think he's saying you did the graph wrong.
But I didn't. When X is -1, Y is 1. When X is -2, Y is 4.
Y equals X squared. It's twice as hard.
Is everybody okay with that? I don't know what I've done, but I've confused my good friend Kelvin. Are you okay? Okay. So everybody's cool? All right. So once you see a squared, you know you're making this shape somehow. Everybody good? Okay. Now, that's the easiest form. Quadratic functions come in 3 different kinds of forms. The first one is standard form. And you guys saw this last year in grade 10. Standard form is ax squared plus bx plus c equals y. Okay? That's standard form. You saw that last year. We factored it. We did a bunch of stuff with it. Yeah? All right. B. It comes in this form. Vertex form. And I'm going to highlight these because these are terms I'm going to be using all the way along. Vertex form looks like this. Ax minus p squared plus q equals y. You're going to learn what they all mean. I just want you to see all forms of it. Okay? And the third form it comes in is factored form. Which is a x minus, and any variable here, x minus e. Anything but x or y there. Okay? Please notice that they all share the same characteristics. They all have an x squared, right?
Or a potential.
Or a potential x squared, like x minus p squared. I'm going to do x minus p times x minus p. There's going to be my x squared. Down here, x times x, there's my x squared. Is everybody good with that? Okay. Now, a parabola follows a pattern, just like a line. And the pattern is this. All quadratics follow the same pattern unless we alter it. And the pattern is this. From the vertex is the lowest or highest point. So from the vertex, if we move 1 horizontally, we move up 1. Right? If I start at 0, I went over 1, up 1. Cool? Everybody understand? What happens if I move 2 horizontally?
You go up 4.
I go up how far? 4. What about 3? What's it going to be? 9. What about 4? 16. Why? Because it is x squared. Understand? And a horizontal movement is a movement on the x-axis. Does everybody get that? You all know this from lines in grade 9, right? Y equals x. I move over 1, I move up 1. I move over 2, I move up 2. If I go left, I move down 1, right? On a line, because a line goes like this. But the parabola curves, bounces up. Everybody good? Everybody's okay? All right. So now, we're going to talk about all of these terms with the basic parabola. Okay? The basic parabola, remember, is y equals x squared. That's the basic parabola. So we're going to talk about all of these terms. We're going to define them on the simplest one, and then we're going to work with some more complicated ones. Cool?
I watched a video that said all parabolas were similar. They're all mappable to each other.
Yes. They're all mappable to this point. Every single parabola is related to this.
Oh.
Okay? So we're going to start with the vertex. Remember, the vertex is either the highest or lowest point. Now, yesterday we were playing with our calculators, and we came across new words for those. If it's the highest point, then the parabola looks like this. And what do you call that highest point? A maximum. If it's the lowest point, it looks like this. And what do you call that lowest point? A minimum. Everyone cool? Pretty self-explanatory, right? Yeah? Okay. Read the next thing there. The equation of the axis of symmetry. There's two things there, isn't there? I want an equation, but you also need to know what the axis of symmetry is. Again, you have to think back to grade 9. If your grade 9 teacher did the symmetry unit with you, some grade 9 teachers didn't, you're going to be okay. If your grade 9 teacher didn't do the symmetry unit with you, then you have to go back to like grade 7 or 6 when you did symmetry. What is symmetry? Both sides are the same, right? So the example we always use is if I draw a line right down the middle of my face, it's symmetrical. It's not really, because your face isn't the exact same on both sides. For example, my right ear is significantly higher on my head than my left ear, which has always made glasses fitting for me difficult. Yes, it's quite, and haircuts have been funny too. Barbers are like, your ears are totally different heights. I know, thanks dude. But it's okay. I've got peace with it, I can work with it. So symmetry means it's the same on both sides. So where in our parabola does that line live? It goes right vertically through the vertex. Okay? So the first thing we need to talk about is the axis of symmetry. And that is the vertical, please highlight vertical line through the vertex. So that's what the axis of symmetry is. But since we are dealing with the Cartesian plane, we need the equation of that. So what is the equation of a vertical line? Not y equals 0, x. It's x equals something, right? It's x equals a number. And that number is the x coordinate of the vertex. Everybody cool? So in our very simple example, what is the vertex of our basic parabola? The vertex is what? Yeah, what is it? What's the point on the graph? 0, 0. Right? What is the equation of the axis of symmetry? It's x equals 0, because it's the x coordinate of the vertex. Is everybody cool still? Yeah? Okay. X-intercepts. Now, we've already talked about X-intercepts. In grade 10, the X-intercepts were of lines, yes? And there was only one. The X-intercept is where the line crosses the x-axis, right? So in a parabola, it's where the parabola crosses the x-axis. So anytime the parabola, and we already know from yesterday, what are our three possibilities there? It can cross the x-axis how many times? Right. 0. It can cross it once, or it can cross it twice. Those are the only options for parabolas. It can be, so our basic parabola has how many x-intercepts? 1. So our parabola has 1 intercept. What's the other word that we use for x-intercepts? AKA, starts with an R, ends with an S, has oot in the middle of it. Roots. Also known as roots of the equation. Everybody cool? Everybody cool? The y-intercept, we know it's where the parabola crosses the y-axis. How many of them are possible? Only one. With a vertical parabola. Parabolas can turn on their side, but you guys don't have to worry about that.
Wouldn't that just be the opposite equation for y squared?
Yeah, x equals y squared, absolutely. Nice job. Where the parabola crosses the y-axis. So it's anywhere where x equals 0. And there, in a vertical parabola, there's only one. What is our y-intercept? The y-intercept equals what? Where does it cross the y-axis? 0. Is everybody cool up to there? Okay. Now, I taught a great many of you grade 10, and a great many of you had trouble with domain and range. Okay, so I'm going to make this as simple as possible. the domain is all possible x values. X values. Okay? Please notice the word possible. We're going to talk about that in a minute. What is the range? All possible y values. Please again highlight possible. Because in this case, there's math and then there's real life. So in our example, the drawing that we have already done, what numbers could I put in for x? No, those are the numbers I did put in for x, Joel. What numbers, what are all the possibilities I could put in for x?
All of the numbers.
Every single number, because I can square it, right? So in math, the domain is x is a set of real numbers. It's every number in the universe, right? Because I can always square it. Everybody cool? Does everybody understand? I will take silence as yes. What is the range? Look at the drawing.
And anything that comes out from x and or
What are all the possible y values? Sydney?
all the squares. The square of any real number.
The square of any real number. So can y ever be negative? No. So y must be greater than or equal to 0. Is everybody cool? Does everybody understand that from math class perspective? Now, shift into real life. Does real life always have negative numbers?
No.
No. For example, does time ever go negative? No.
Has a bad day.
So in real life, we have to be careful about our domains and range, right? In real life, if I throw a ball off a building, can it ever go below 0 in height? No, because what's going to happen when it hits 0?
Unless you set 0 at your feet.
It's on the ground, unless I set 0 at my feet. But eventually it's going to end, isn't it? When you throw a ball off of somewhere, eventually it stops going down. Does everybody understand? So in real life, you have to be careful about the domains and range because real life restricts domains and ranges. Is everybody cool with the basics? Everyone's good? Okay. I am going to ask you guys to use your calculators to graph 1, 2, 3, 4, 5, 6, 7, 8 of these. Now listen, don't start right now. Okay? This is what you need to do. 1, you need to go to the y equals button and enter the equation. Then I want you to give me the vertex. Then the vertex, which on your calculator, where do you find that? Second, calc, max or min. And then I want 4 other points from the graph. That is second, calc, value, and you enter your x coordinate. Okay? Everybody cool? I'm going to do the first one on the screen because it's the easiest one. Even though we've already graphed it, I'm going to show you what I want to, what your page needs to look like. Okay? So I get my calculator out. y equals, clear everything here, y equals x squared, right? Graph. Change my window to standard, zoom, 6. There it is. So now I go to my graph and I sketch it. Goes right through the middle, looks like that. That's step 1. Step 2, find the vertex. Second, calc. Is that vertex a minimum or a maximum? Minimum. So 3. I'm to the left of it, enter. I'm to the right of it, enter, guess, and it's 0, 0. Because you can see it's exponent -7, exponent -13. So there's 7 zeros and 13 zeros. So that is my vertex equals 0, 0. And I want 4 other values. Second, calc, value, x. How many do I have to put in? 4 more numbers. Got it? Use 2 negatives, 2 positives. So -2. When x is -2, my y value is 4. So -2, 4. -3, 9, +2, 4. +3, 9. Does everybody understand what I want you to do? And you are going to do that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more times. And that will take you to the end of today. I want you to stop there. Do I make myself clear? Everything up to the fancy writing for the patterns of vertex form. And you make sure your practice test is done for tomorrow, first thing. Everybody hear me, Michaela Graywall? Okay, everybody good? Please remember you are having a quiz on, yeah, it's a quiz, it's not a test, on Thursday. Everybody cool? Yes, it is a collab day Thursday. Joel.
When you put in for like when you calculated and then you went to the middle,
Yep.
you found your left and right boundaries.
Yep.
And your negative number.
Yep.
Is that why it's
No. It's because, Joel, when you look, second calc, minimum. So left boundary, I was there. Bring it around. Right boundary. And this is something you guys all need to understand. Look at this. Exponent -7. That means this would move 7 spaces over here. What would go in the holes? 0. So this is point 0.0000000000001. So it's 0. And this is point 14 zeros over here. So 1 quintillion, which is effectively 0. Do you understand what I'm saying?
Do I round
That's
that
how
up to a
those-
quintillion?
Okay? Jenny. So go. Have a good day. Alright? Some of them are going to look normal, and that's why it's a guess. Right? Because where I stopped it there and where I stopped it there. But watch this. Second calc value. If I enter 0 for x, I get 0 for y. Right? Because your calculator is capable of thinking in 1 quintillion. Right? Yeah. Okay. It trusts that you know that 1 quintillion of something is 0.
I mean, you can
Yes. Yeah. Is everybody Gouda?
Swiss.
Great. Carry on.
I don't know what calculator is doing. So every time I try to get a graph, it's like it's almost really zoomed in, but I can't zoom out.
Yeah. Yeah. Yeah, you've got something set on your. Yeah, so window, no, sorry, not window. Zoom 6. That'll put you to the nice normal one.
Okay, thank you.
Okay,
Didn't want to calculate that value.
which one?
I tried to put in 200 for X. It just said error. Really didn't. No, it doesn't want to do any numbers above like 10. Value 11.
I don't.
Error invalid. Oh wait.
For the very first one?
No, it's for the fourth. It's for the fifth one. That makes sense now. Ooh. You know what I think is stupid about English people and math?
What?
That they say maths.
I don't mind it.
I find it annoying because it's clearly not a plural word.
But there is more than one kind of math.
Yeah, but you don't go,
It's
I'm
mathematics.
going over here to do maths. I'm going to do some maths over here. I got 2 maths.
So I press second calc. Second.
Well, first of all, why would you punch that in that way? Why wouldn't you just punch in what you see?
I was scared.
Why? I mean, you're right. Don't get me wrong.
I just got scared.
Huh. Bracket x plus 3, close bracket squared. Graph it. So there it is. Okay, so now we need some values, right? So is it a minimum or a maximum?
Minimum.
Second, calc, minimum. Left boundary. Enter. Right boundary. Enter, enter. 3. Negative. But you already know that, because of what we did on paper. Because x minus 3, right? If x was negative 3 plus 3 would get me 0, which is what I want. Right? But anyway, so what were you actually asking? Oh, that. Okay. Of course.
I tried looking up why it gave me 0.9999 instead of 1, by the way. Couldn't find it, but I assume it's because like at some point it does like 1/3 and then gives you, but I didn't.
Yeah.
Is that why I did it? Because it gave me 1/3